Hi, welcome to this video on roots of a quadratic equation. Now this is on the further maths course, and so some of the roots can be complex numbers, so as opposed to on just the normal A-level course where you wouldn't be dealing with complex numbers. So this is purely in terms of the further maths course. Now if we think back, this is going to be very similar to what we looked at in chapter 1. It was in part 1.7. So you can always have a little look back at that. But if you look at that one when we're dealing with it in terms of z, very, very similar. But we always had the coefficient of z squared as 1 in that one. But here we're going to look at it with the coefficient of that x squared. So we're looking at ax squared plus bx plus c equals 0. Now, we are looking at this when a, b and c are real constants. So they can have two real roots, one real repeated root, or a pair of complex roots. So if you remember, it's a conjugate pair. So two complex roots, but they come as a pair. So those are our three options. Now, just like before, we're going to talk about when the roots of the equation are going to be alpha and beta. So if that's the case, what we will get is that this is going to be x minus alpha multiplied by x minus beta, and we're going to have the a factorized outside because we're going to use that coefficient of a in this one. Now if I expand these brackets, I'm going to get x squared. Obviously here we're going to get x times the minus beta, so minus beta x, the minus alpha times x, so minus alpha x, I suppose I could have written them the other way around, and then plus alpha beta from the negative alpha multiplied by the negative beta. So this is what we've got. Now if I expand this bracket, we would have ax squared, we'd have minus a alpha plus beta times x, and we'd have a alpha beta. So if you remember from previously 1.7, this is the same thing that you're used to seeing then, but obviously we weren't dealing with a, as a was just 1 in those cases. Now if I compare this to this equation, which I'll just rewrite here so you can see it nice and easy, then obviously a equals a, that bit, you know, that's unchanged. But if I look at the x term, the coefficient of x, I can see that b is equal to minus a alpha plus beta. And I can also see, looking at the constants here, so c is equal to my alpha, sorry, a times alpha times beta. Okay, so a very slight difference to what we'd seen in the previous unit, but just because we're using that coefficient of a. Now if I rearrange these, I can divide by my negative a there, and that gives me the alpha plus beta that we'd seen before, and this one divided by the a gives me my alpha times beta. So those alpha plus beta and alpha times beta are still important, still like before, but this time we just have that coefficient of a in there as well. So using what we talked about before, this sum of the roots will be minus b over a, and the product of the roots will be c over a. Now let's start using this initially within some questions. So we're just going to get used to it, build it up before we get into some serious questions. So straightforward one, not obviously one you'd have in an exam, but just one to get you used to using this. So my first part, we want to find alpha plus beta. So alpha plus beta. And this is minus b over a. So my alpha plus beta, so you think up here, here's our three values, I'll pop those down. So we got a is 2, b is 5, and c is 2. So minus b, so that's minus 5 over 2. Nice and easy. Looking at b, we got alpha times beta. Now this was c over a. So if I again look back at my values that I've written here, c is 2, a is 2. So our alpha times beta is just 1. Now c, we've got 1 over alpha plus 1 over beta. If I make this a single fraction, then it means that I'm going to have this over alpha beta, aren't I? I'll take an extra step on this one. I wouldn't normally, but I will take an extra step just so you guys can see. So if I make this over alpha beta, I'm going to have beta over alpha beta, because obviously then the betas will cancel, still leave me 1 over alpha. Equally making this fraction an equivalent fraction over alpha times beta would be here, and you can see then your alphas would cancel. So just think about, you can multiply these and cross multiply however you want to kind of do it. I know it's that's not technically correct, but it is how I see a lot of people just thinking it through that way. So here we have alpha plus beta on the top over alpha beta, as the fractions have the same denominator there. And we already worked these out from the previous questions. So alpha plus beta is minus 5 over 2. Alpha times beta is 1. So this is just minus 5 over 2. And then the final part is d. d is alpha squared plus beta squared. So for this one, we want to think about it a little bit differently. So if I think of alpha plus beta all squared there, and I'm just going to pop this in purple. If I expand this alpha plus beta squared, I'm going to get alpha squared. I'm also going to get a beta squared out of it, aren't I? But I'm also going to have a third term that I don't want, which is the 2 alpha beta. So expanding this is going to give me 2 alpha beta like that. So if I expand this, this is what I get, which is very similar to what I want, but I don't want this. So that is what I have to add on, well, subtract I should say, 2 alpha beta like that. Now this is exactly the same as this, it's equivalent. Okay, but it's also in a form that I can answer, because alpha plus beta we already know is minus 5 over 2, and alpha times beta is 1. So now we've got 25 over 4 minus 2, and that is 17 over 4. Okay, so just a little bit of algebra manipulation there. Let's have a look at a different example. So for this one, we have an equation, but we don't know any of the values for a, b, and c, but we are told that they are integer values. And we have our 2 roots. So again, our starting place now is our alpha plus beta, and our alpha multiplied by beta. So the sum and the product of the roots. Okay, so alpha plus beta, a half plus that minus 2/3. And that gives me minus 1/6. And then for the alpha beta, we got half multiplied by minus 2/3. And that's going to be minus 2/6 or minus 1/3. Now then, I also know that my alpha plus beta was minus b over a. So if you remember, alpha plus beta is minus b over a. Okay, so therefore minus b over a is equal to minus 1/6. And alpha times beta is c over a. So therefore c over a is equal to minus 1/3. And then from here I can create my equation, and I can think of it in more than one way. So for example, I can jump straight in with x squared plus 1/6x minus 1/3 equals 0. And then multiply everything by 6. So you get 6x squared plus x minus 2 equals 0. And that is one possible scenario, one possible equation. Obviously I can have multiples of this. Okay, so I could have multiplied through by anything where these two are common. So I could have multiplied through by 12, I could have multiplied through by 18, and so on, okay, to get an equivalent equations. Now some of you might be thinking, oh, that's a little bit confusing, why has he jumped in with the 1/6 there and the minus 1/3 there? Well, what I've done on this one, and I'll show you in purple, is I've just thought of this: ax squared plus bx plus c equals 0. And if I divide through by a, I get this. Okay, and from here, b over a is 1/6, and obviously this one was already positive, so we've got it there. So that is one way of looking at it. It's how I did it just then. The other way is to look at what is the actual value of your b and your a. You could have effectively done it like if we were going from this value here. So for example, I'll do this again in purple. Minus b over a is minus 1/6. So b over a is positive 1/6. And we had c over a is minus 2/6. So from this we can see that a is 6, can't we? So a is 6. We can see that b must be 1 and c must be minus 2. So that's the other way in which we can look at it. Okay, and again we can have multiples of these values. And it's completely up to you how you go about using it, what you're more comfortable with. But effectively from what you've got here, you're finding the values of a, b and c. And there's not just one possible answer. Multiples of that answer will also work. So we can obviously hopefully see that this equation I've just written here is equivalent to this one here. It's going to have the same roots. Okay, and it's important to remember that. Hopefully that makes sense, because I feel like this is the way in which you're going to start using this a little bit more than with the first example. So I think that's a good start to our roots of quadratic equations part. What I'll do now is going to give you 5 questions for you to have a go at, and as always I'll put the answers at the end. I'm just going to take this moment to just say, don't forget to subscribe if you haven't done so already. Please, if you are finding these useful, feel free to tell your friends and anyone else who is interested in maths or on the maths courses, and like, comment, and so on. Okay, every little helps me. Thank you for those of you doing it. Brilliant. Anyway, let's get stuck in. Now, I sped the other ones up, but I thought I'd slow down and talk you through this answer, as I didn't do an example like this. But it is the same start pretty much, well, certainly where it to be. But looking at A, remember, if it's complex, then they come as a conjugate pair. So our beta is going to be 1 plus 3i. Now for part B, we have alpha plus beta, and that is going to be, well, I'll write it out, but it's obvious, isn't it? If you remember that, the imaginary part is going to cancel, so this is just going to give me 2, and alpha times beta. Again, this is quite quick to do. If you remember, 1 times 1 is 1. We're going to get plus 3i minus 3i, which will cancel out, leaving with minus 9i squared. Remember that I squared is -1. So we got 1 plus 9, so that is 10. And with both of these then, if you remember, we have minus b over a is equal to 2, and c over a is equal to 10. They told me that a equals 1. Okay, obviously if it didn't tell me that a equals 1, then again, like the others, I can have multiples. Usually go with the smallest set of integers here, but any multiples of. But in this case, a is 1, so we know that b is minus 2 and c is 10. So here we have x squared minus 2x plus 10 equals 0. Okay, hopefully easy enough. Worth noting that by saying that a equals 1, there is only one possible answer. Okay, if, for example, just in case those of you are curious, if we didn't have this, so if that wasn't given and we had to find our values of A, B and C, then the process is pretty much the same as, you know, the previous ones. I could have this as an example. It would still give me this as my first possible answer, but since A can be other values, I can have any multiple of it. For example, this and so on. Okay, so if it doesn't show that A is 1, for example, or gives me one of the answers, sometimes they could give you B or a C. Those would denote specific equations. This means without giving it, there's multiple answers. Again, this last one's a little bit different, certainly different to the examples, so I will talk you through it. So we are told that the roots of this equation are reciprocals of each other. So if one root is alpha, the other root is 1 over alpha. That's what we're thinking of this time. Okay, so these are my roots. That means then if I'm thinking of my alpha plus beta, scratch that, just looking at the question, we know these, we're actually just finding this value, and if we remember, this is just going to be C over A, which is alpha times beta normally. So my C over A is just going to be my alpha times 1 over alpha. So that C over A is just 1. However, if I look back to the equation here, we can see that C is equal to K, isn't it? And so that I can get this form, divide this one by A. So C over A is K over A, but A I know is 4, isn't it? So this is K over 4. And C over A is just worth 1. So 1 equals K over 4, or K is equal to 4. Kind of long, roundabout way of doing it there. I'm just trying to hopefully help it make sense. Hopefully found this video useful. The second video in this one will follow fairly shortly in a day or two. Okay. Let me know in the comments how you found it, and yeah, let me know. And don't forget to like and subscribe.